Okay, here we will talk about the motions of an object in a plane, and we will also derive about the expressions for the position vector of a particle in the xy plane. So as you can see in this figure, this point P corresponds to the positions of the object at any time, and this point P, it is having a position vector r arrow. That means the position vector with respect to the origin is OP arrow, and this OP arrow is equals to R arrow. Okay, now if the coordinates of this point P, let's say it is x comma y, then if you drop a perpendicular from this point P on the x-axis, then you will get the distance OA, and distance OA here is equals to small x. Similarly, if you drop a perpendicular from the point P on the y-axis, right, then you will get this distance OB, and this OB is equals to y. Okay, now this OA and OB, they are the rectangular components of the position vector OP. So therefore, I will resolve this vector OP into two rectangular components along x and y axis. And for that, we use the triangle law of, we use the parallelogram law of vector addition. So by parallelogram law of vector addition, it says that the diagonal is equals to the sum of the two adjacent sides of a parallelogram, that is OA plus OB. Okay, but this OP arrow here is equals to R arrow, and how much is OA arrow? This OA arrow, it is equals to magnitude is x and the direction is I cap. OB arrow, OB arrow is equals to magnitude is y and the direction is j cap. So this is the expression for the position vector of a particle moving in the xy plane. Okay. Next is expression for displacement vector. As shown in this figure, we consider a particle moving in the xy plane. And suppose at a time t, the particle is at a point at this point P and having a coordinate x comma y. And at a time t dash, the particle is lying at this point P dash with coordinate x dash y dash. Alright? Please note down here that this curve, it stands for the, or it represents the path along which the particle is moving. Now, OP here is the position vector of the point P with respect to the origin, and it is represented by the symbol R arrow. And this OP dash, it represents the position vector of the point P dash with respect to the origin, and for that we denote it as R dash. Okay, so as the object move from P to P dash, then the object here is changing its position, and so we say this PP dash as the displacement vector of the object, and for that displacement vector we write it as delta R arrow. Right? So let us use a triangle law of vector addition in this case. So when you apply the triangle law of vector addition, then you will find that this OP arrow plus PP dash arrow is equals to OP dash arrow. isn't it? Or instead of OP, I will write R arrow, PP dash, that is the displacement vector delta R arrow. Instead of OP arrow, OP dash arrow, I will write R dash arrow. Or we can say delta R is equals to R dash arrow minus R arrow. Okay. If you further express this position vector in terms of rectangular components, then we can write delta R arrow is equals to, instead of R arrow, in terms of its component, I will write X dash I cap plus Y dash J cap. Okay, because X dash and Y dash, they corresponds to the coordinate at the point P. Similarly, instead of R arrow, I will write I X I cap plus Y J cap. Again, X and Y here stands for the coordinate of a point P. So, this delta R arrow is equals to, now I will combine the term. I will take X dash minus X and then I cap taking outside, and then plus Y dash minus Y and then J cap taking outside the bracket. Or delta R arrow is equals to, now what is this X dash minus X? Final position along x-axis minus initial positions along x-axis. That is the change in the positions along x-axis. So for that we will write delta x, and this is I cap, plus similarly y dash minus y, I will write it as delta y, which means the change in the positions of the object along y-axis. Okay, so this becomes the expression for the displacement vector in terms of its rectangular component.